Hi guys, and welcome to another IBM BPM technical tutorial. In this edition, what we're going to look at is integrating the IBM BPM product with an IoT piece of technology. So what I'm going to do is I'm going to take you through the demonstration, and then we're going to look at what it takes to actually build this out itself. Now, I'm not going to go into all the gory detail, but there's certainly going to be enough that you can see exactly what we did and reproduce it yourself as needed. So the high-level story here is that we have a BPM process. We're going to create ourselves a little BPM process where we want to dynamically enable or disable our car. So for example, imagine it was stolen or lost or whatever other reason, and we wanted to remotely disable it. Perhaps we also want to grab sensor data from it. Maybe we've got a teenage kid and we want to determine the average speed that it's been driving at, and all sorts of good things. So we can imagine that our car is instrumented with IoT technology. It can receive events or commands, and it can publish events. We're going to look at the IBM Watson IoT technology framework, which is the cloud-hosted technology for providing the connectivity to the IoT devices, and we're going to interact with that through the IBM BPM process. So this is the high-level story. So now let me take you through what it looks like from the external's perspective. So what I've done is I've created myself a simple BPM process human service here. This is a service that we'll go into more detail later, but it basically presents a screen to the user where the user can can enter commands to enable or disable the car or retrieve the sensor data. So let's have a look at that from a screen perspective. Here it is. I can enter my vehicle identifier, and I can enable the car, disable the car, or retrieve the sensor data. So now let's look at the actual device. So right now the car is disabled. If I want to enable it, I click the enable button. Remember, this is a BPM coach. I click the enable button, and as you see, the light lit up on my little piece of electronics here. Now this is a demonstration, remember. This could be wired into the ignition of the car or some other mechanism. To disable it, I click disable, and the light goes off. Enable, the light goes on. Now you may be saying to yourself, well, that's not very exciting. You're clicking a button here and a light's going on and off. But here's the reality. This is all through the internet. This is all through the Internet of Things. This is leveraging the IBM Watson technology. And this little piece of electronics you see on my desk, this could be anywhere on the planet. This is not physically wired to my PC running my BPM environment here. My BPM process could be self-running on the cloud or running in my enterprise, and when I execute these functions, enable and disable, what we're doing is we are communicating and interacting with a physical device located somewhere on the planet through the Internet of Things. And if I want to retrieve the latest sensor data from the device, I click on this button and we are retrieving the latest sensor data from the vehicle. If I click it again, we get the latest sensor data. So what we're doing is we're both sending commands to the remote vehicle and we're retrieving sensor data from that vehicle. So hopefully you see what we're going for here, and for the rest of this video I'm going to take you through some of the steps necessary to achieve this. So in our story, we're going to find that we've got a number of logical components. The good news is that all these components plug together absolutely beautifully, and each component seamlessly integrates with all the others, and they're all hosted, by and large, all hosted on IBM's Bluemix technology. That's IBM's developer platform for the cloud. So we'll start with the foundation, and the foundation is that our BPM process will eventually be making calls out from the BPM process to the IoT device to get things done. So BPM will be saying, hey vehicle, enable yourself, or hey vehicle, disable yourself, or hey vehicle, get me or return to me the latest sensor data. Now the way that we make requests from within the BPM environment is to use the REST-based technology. That's the lingua franca these days for making external service calls. And the way that we describe service calls to BPM is to use a technology called Open API, also known as Swagger. And what Open API does is it allows us to describe the interface to a service that we wish to call. If you're old school like myself, you may think of this very much like the web services description language that we had with web services back in the late 90s and early 2000s. So with Open API, we have the ability to describe the services we want to call. Now, using IBM's API Connect Designer, we can create ourselves, and I've already done this, we can create ourselves a Open API specification. And this Open API specification that we're seeing here is the technical description of the services that I want to have BPM call. There's a service that I want it to call which enables the vehicle, which takes as an input the state, which is either true or false. The vehicle will be enabled or disabled. I also want to be able to get the sensor data, and that will get the sensor data. So this is the Open API specification, which is common across various technology platforms for describing the service that we will eventually see BPM call. Now, the great news is that in the past, people used to bring up their notepad and they used to edit these Open API definitions themselves, complete with all the typos and the issues involved in that. Using IBM's API Connect, we have a very, very elegant screen designer here where I can come through this, I can define all the security things, and then I can define all the service interfaces that I want. So if, for example, I want to get the sensor data, I can come in here and I can describe all the parameters and all the return codes at a very, very high level with entry assist and data type support and all kinds of good things. The result from that is the Open API description. So I never ever had to type any data in here in this editor. Instead, I defined my service interface to provide two logical services, one to retrieve the sensor data and one to enable or disable the vehicle. And I did that at a logical level, and the output of this is the Open API description, which will then be provided to the BPM environment. Now let's take a look at the Watson IoT platform. The Watson IoT platform is where we define and manage devices, IoT devices, that are going to network connect to IBM's managed cloud. So we can imagine that we might have hundreds, thousands, perhaps even millions of connected devices that we wish to manage. So using the Watson IoT platform, we can define the templates of those devices and then add each device, or have each device add itself as a managed device through the Watson IoT platform. What this separates us from is having to worry about connectivity to the actual devices. The Watson IoT platform provides the logical framework where each device is going to have some unique identifier, otherwise how do we know which device we're targeting? And then we interact with the Watson IoT platform through excellent security and send in commands and receive events coming from those devices. And Watson does all the heavy lifting of maintaining connectivity to those devices. Should those devices be offline or not in network proximity, it stores commands and stores events. We get to manage devices so that we can enable and disable them. We can measure qualities of service and a whole bunch of other considerations relating to the connectivity of IoT devices. devices. So within the IBM Bluemix environment, I created myself a Watson IoT platform service. I defined a particular device type, which I called a vehicle, and then I defined an instance of that vehicle. I called it vehicle number 1234. And in that description of the vehicle, I gave it property types such as the weight of the vehicle and the average mileage, and allowed it to receive incoming commands such as enable and disable. And this was all done through the Watson IoT platform. Didn't have to do any programming, any coding, merely declarative changes. So Watson IoT provides all the technology I need in order to interact with the IoT devices. Now we start to plug the things together, and what I've written here is what's called a Node-RED flow. Now Node-RED is a great sandbox environment for building out connectivity things and worrying about data routing. Whether it would be used in production is another question, but for prototyping something, you couldn't ask for anything better. And this Node-RED environment is again hosted by Bluemix. And what the story is here is that this Node-RED flow, that's what we call these things, this Node-RED flow is servicing two incoming REST requests. One REST request is a REST request we call enable, and the other REST request we call sensor data. So let's look at one at a time. The enable incoming REST flow into this environment will match the open API description that we described using API Connect. So using the API Connect, we described what a service call, a REST service call would look like, and when we call that REST service call, this becomes the endpoint of the service request. So what we do is we receive, for example, the enable or disable request to disable the engine. From that incoming data, we extract the vehicle ID so we know which vehicle we're going to get. We also extract whether this is an enable or a disable. And then we invoke the pre-built IBM IoT component, which sends the request to IBM's Watson IoT platform, which in turn sends it all the way out to the IoT device. So this step, receive the incoming request, extract the data, send it through IoT, and the rest is just debugging that I've left in. So this is all that is necessary to transform an incoming REST request into an IBM IoT transformation. Now the get sensor data, this is a request from, again described from the Open API request, that when called wishes to retrieve the sensor data that has been published by the IoT device. Again, we extract the vehicle ID for the data that we want to retrieve, and then we make an HTTP request to the IBM IoT data warehouse, where all the all the event data that's been coming in by IBM's IoT into IBM's IoT platform from our vehicle is retrieved. We map that into the response that we want to send to our original get request for the sensor data, and we send it back. And this concludes all the components that we need to develop on Bluemix in the server. So let's recap. We described a service interface which is going to be implemented by this message flow. That service interface is eventually going to be called by BPM. When those services are called, this flow runs up in the cloud, retrieves the information from the request, and makes the corresponding IBM IoT calls to interact with the back-end device. As you can see, no programming required. So now let's move onwards. The next thing we're going to look at is the software which runs on the actual IoT device itself. Now that's going to be very, very open to discussion. I happen to be using a little microprocessor called Chip. Lots of folks use Raspberry Pi. Others use Arduino, and none of those would ever be used in a production environment. Instead, what we would have would be dedicated microelectronics on its own module, probably about the size of your thumbnail, rather than these big hulking great modules that are for the hobbyist and the prototyper. So by and large, the production solution would probably be written in a low-level micro language like C or C++, but for our demonstration purposes, we're running on the chip, and the chip, like the Raspberry Pi, runs Linux, and Linux runs Node.js, and Node.js allows us to write our code in JavaScript. So here, what we're seeing is the application logic, which is running on my actual IoT device. Now, I'm using the IBM framework, the IoT framework. So the coding for that is incredibly simple. And what we do there is we have the ability to receive commands, and this is my device client. I'm saying that when a command comes in, call this callback function. The callback function looks to see whether the enable state or the disable state is set and changes a GPIO, a general purpose IO pin on my chip device, which lights up or extinguishes an LED. Periodically, every 5 seconds, I'm recalculating just random numbers based on the weight of the vehicle and the new mileage, and I'm publishing those out to IBM's IoT. So we've got commands here which are being received by Watson IoT and sent to the actual device, and my actual device is continuously publishing new data every few seconds. And this is, again, my illustration, but this is actually running on an IoT device, and it's a real world thing. And this is the endpoint technology that is the end of the Watson IoT transmissions. So from a Watson perspective, all we have to do is say that I am a publisher and I am a subscriber, and the Watson IoT classes and packages handle all the connectivity up to the Watson IoT platform running on Bluemix in the cloud. It would be remiss of me if we didn't end this tutorial with the discussion of the BPM interactions. After all, this is a BPM technical tutorial. So if you followed the story up till now, we created ourselves an open API specification which described a REST service which, when called, targets a flow which is hosted by the Bluemix environment up in IBM's cloud. When those REST calls are made, the flow executes and in turn translates those calls to invocations of the Watson IoT framework, which knows how to drive communications over the internet, which knows how to drive the IoT component, where the IoT component then receives the data and performs its work. So what's left is to design a BPM environment where BPM is going to invoke those services. So in the latest version of the IBM BPM environment, we have the capability to define what we call external services. Now by clicking here, we can bring up an external service. That then allows us to create one. We can come over here, define the file which contains the Open API specification. We can specify that file. We can go through the wizard, and then it interprets that data and builds the corresponding BPM services, which when invoked will cause those REST calls to be made. And this is all wizard driven. Now what that means is that we end up with services which perform the calls to the through the Open API description, through the REST API, without us having to do any further work. All the mechanics of making the REST calls, formulating any JSON payload data, communicating with the endpoints, taking care of security, and all those other things are handled on our behalf through the IoT service definition. It describes the inputs and outputs data, data, describes the commands that we can specify as input and output, and handles all of the heavy lifting for us on our behalf. What then remains is for us to invoke those services at the right place in our process. How those services actually work is of no concern to the BPM designer. The BPM designer merely sees those as black box services that, when called and passed in the right parameters, for example, for the enablement function, we want to pass in the vehicle ID and the state, whether it's enabled or disabled, the designer of the BPM solution doesn't give a hoot, doesn't care how this is implemented. The fact that under the covers, behind the scenes, it's making a REST request to the cloud, which is handled by a flow, which interacts with the IoT framework, which sends it out to the final device, absolutely of no interest to the solution designer. The solution designer can basically focus on the function of the process that they want to design. And of course, in my solution here, I created myself a human service. In that human service, I created a coach. And in that coach, I defined some very simple fields to display the data, and some buttons here that, when pressed, call the send enable service, either with the enablement of true or false, or retrieve the data based on the function. And that's about it. We've covered all the good topics that we wanted to cover through this. There is a ton more to say. We can go into the Watson framework. We can look at its management consoles. We can look at its dashboards that are pre-built in. When the BPM process runs, of course, what it does is nicely interact with the back-end system. And when I hit the enable or disable button, that's what causes the request to be sent, which we saw at the beginning of the process. This has been a long video, folks, and I hope you've found something useful in here. I look forward to making more of these videos in the future. But for just now, guys, I appreciate your time. Thanks and goodbye.